Good afternoon, everyone. We're just sorting out some sound issues. That one and that. Which one? Shift end? Function on F1. Nice. Afternoon, everyone. I'm not sure everyone's met me. My name is Philip. I'm part of the Prometheum Carbon team. Just to check, can everyone hear me? Ahmad, I can see you. Can you hear me?
Yeah, I can. Just switch off Mike's video, please.
I tried, but it's a funny machine.
Yeah, we've got a
Faces, F1. Hang on.
That's okay, Mike, don't worry.
Oh!
Mike, it follows you. There's something wrong with it.
Yeah, use it for finding Waldo in the future.
Today is the third session in the training sessions for methodology developers for the ICS platform. And today we are going to cover, first of all, we'll do a little bit of a summary of the previous sessions, just to recap on what happened there. But today we're specifically going to give a very high overview of the platform. We'll talk about where one goes to access it, what the registration process is, where you go to log in. We'll talk about how one goes about navigating the platform, where to find some of the relevant documents that you'll need, both for developing methodologies, but also from a governance and also a modeling perspective. We'll then talk more specifically about where to go and see information about methodologies. We'll touch on projects, although it's not the main topic here. And then we'll talk about how you start developing your own methodology. From the previous sessions, what we learned about was the purpose of the component methodologies. And in the ICS, what the component methodologies they are for is to create a framework for use in creating projects. So the component methodologies define a template for collecting data and information and calculations that are needed for developing a carbon emission reduction project. So within the component methodologies, the framework is very broad in the sense that you can define what is required by your component methodology. The standard provides some guidelines in terms of what a component methodology needs. And we've defined these three main areas where information is needed. First of all, the applicability criterion. So when do you need a new component methodology? And applicability criteria would define when you need a new component methodology. So first of all, if there is no methodology for the type of project that you're looking at, and that would then specify things like the technology you're looking at, what sort of monitoring procedure you're going to go through. Are there any specific types of technologies used for the measurement of different parameters? So these three areas really define whether you need a new component methodology. As the system gets developed further, there'll be more and more component methodologies. So there should be a a smaller need as time goes on for newer ones. But at the moment, there are just certain default methodologies that we have there. And the users can then develop those further depending on their specific requirements. So in the previous sessions, we defined the types of component methodologies that cover certain topics within a project. All projects require the project details, additionality, baseline, and monitoring component methodology types. The permanence component methodology is specifically related to land-based projects. And this is how you show whether there is permanence in that project. And then the last component methodology type there is related to tagging. And tagging could be a way of labeling the carbon credits in terms of the additional features that they may offer. So this could be related to certain markets or given supply chains or co-benefits. If we look at each of those component methodology types and what their requirements are, this is very useful in terms of providing a framework when you're developing your component methodology. Project details is the most generic one, and it's really looking at how you describe where your project is, what are the boundary of your project, who are the stakeholders, are there specific legal requirements, does it align to certain other frameworks? So this provides a broad description of your project. The additionality component methodology, this is really providing a means to prove additionality. This can include the calculations that may be required for that. And then there's certain examples that we provide here for how one could develop your additionality component methodology. So you can use an investment analysis, you can use a barrier analysis, and you can also look at other methodologies that are available or that you want to develop within the ICS.
The additionality, the automatic additionality for PICO projects and technology penetration rate, does that mean you don't have to do very much work at all? If the project is so small, that section doesn't have to be very detailed.
So because you're defining what's required to prove additionality, you would then specify what you think would be suitable for automatic additionality. This would still then go through the Environmental Integrity Committee to check and see whether it's in line with the guidelines in the standard. So you can propose something that would then go through that review process that would then set a precedent for what can happen.
The order in which you do these things, if you're concerned about additionality, are you able to go to the committee and deal with that before you continue with the rest of the study, which could be quite intense?
Yes, so the main thing when you're developing your component methodology, you don't necessarily have a project yet. And what you're doing is you're showing by concept how the additionality would be evaluated and the information that would be needed. Now, when someone comes to doing a project, they have to use the approved methodology. So that would be the first step in the process, is conceptually showing that your additionality component methodology is suitable, and that would have to be approved before you can actually develop a project for it.
So we can do checks along the way.
Yes.
Say, guys, do you feel this is additionality meets the
Yeah.
the hurdle for additionality? Yes, it does. Okay, carry on. Yes. Or sorry, methodology.
And if there's an existing additionality component methodology in the platform, you can use that. And then you would have to comply with the requirements of that component methodology. The third one, component methodology, is the baseline. And this is to do things like the calculation of what the baseline emissions would be for your particular project. So if it were a landfill gas project, it would be the emissions from the landfill before there are any interventions for emission reduction projects. Quite often the grid emission factor uses standardized baselines in the other standards. One could also develop a baseline methodology for a grid emission factor for the ICS. Then the fourth one is really the largest and more complex type of component methodology, which defines the procedure that you would use to monitor the different parameters within your project. So the amount of electricity generated through your renewable energy plant, or the emission reduction from flaring landfill gas. You would then need to define all the different parameters related to that. Temperatures, flows, pressures, and most importantly, you would need to show what the emission reductions calculation process is. For the permanence, there it's a lot is related to risk in terms of what could happen to prevent the project from being permanent. Whether that land is owned by somebody else or managed by somebody else, or do other people have access to it? Is there a risk to losing biomass that you've sequestered? The tagging can be for a large variety of different co-benefits or project types.
Question on the baseline point. What is level of service?
I don't know. Robbie had it in the last presentation, so I just included it in the summary here, but we can confirm that. Then there are certain things that are not needed in terms of the component methodology, and that's because it's a template, it's a framework that's used for projects. So you wouldn't capture project-specific information in a component methodology, because that'll be captured when you create your project. So you will give the project name, the project details, all of that is part of the project. So you don't need to define that in terms of the component methodology.
Would you include a space?
You would include a space, yeah. So if you're creating a project description component methodology, one of your questions would be, what technology does this, will your project use?
Location.
Yes. So within our ICS platform, a component methodology is set up as a very generic construct. So all of the component methodologies would be created in the same way. It's just the questions that you would pose for the project developer would vary from component methodologies to component methodology. Okay, so that's a very brief recap of what was covered in the last sessions. So now we'll move on to the actual platform. There are a couple of ways to access it. There is a website which is there to provide generic information about carbon emission reductions, contact details for different people at Freedom Trees or at Prometheum. And within that page, then there's a link to the actual ICS platform, which is used for doing the emission reductions projects. You can access the platform directly. It's just the URL, what you type into your browser. So to access the website, it's inclusivecarbon.org. To go to the platform, it's app.inclusivecarbon.org. When you, if you haven't used the platform yet or before, you would then go to inclusivecarbon.org and you'll click on the register button. And there it'll ask the typical type of information that you would use to register on any website. Name, telephone number, username, password, and then the typical "I'm not a robot" sort of things. Once you've done that, you'll then get an email that asks you to confirm that it's your email address. And then once you've done that, you can log in using your username and password. Before you've logged in or after you've logged in, either way, there's a navigation menu which appears on the left-hand side of the screen. In this menu, you can access different bits of information. The first thing is governance, which is really about the governance structures that are in place. Things like who are the committees, are there, who are the auditors that are registered on the platform, and so on. We also provide links to documentation, such as the standard, the methodology manual, the manual used for the language for writing the different equations within the platform. In the public space, there's also information related to projects and to the component methodologies, which have expressly said that they're willing to show what's happening or what they're busy with. And only once they pass a certain level of development. We'll look at those menus and projects in a moment. What I thought is important is just to show you what documents are there, and specifically for the component methodologies, which are the important ones. So of course, the methodology manual, that's a key one. And the standard, because that defines the principles under which you need to develop your methodologies. I did want to touch on the this is the actual platform. I can find my mouse. Okay, there it is. So what I wanted to show you here was, in terms of the documentation, this manual for the programming language is a very detailed and long document. Actually,
Second edition.
I'll do what I wanted to highlight here was you don't need to know the whole thing. A lot of the things within that manual are actually built into the platform, so it hides details like you don't need to know what database it's connected to or what tables in the database it's connected to. The ICS takes care of that. So there are certain sections which I'll point out here that will be relevant when you start developing your component methodologies. When we start talking about things like sets, Set is really a list of items, and you would use a set as an index for a parameter that you have. So, for example, you may have multiple landfill sites in the project, and you can create a set with the names of those sites. And then in your calculation, you may want to loop through the different sites that you have in the project. And you would then use a set called sites, and it would have site 1, 2, 3, 4, 5. And you would then use that within the calculations to reference those sites. So sets is an important thing to understand, and how they're used for indexing different dimensions of the parameter that you're looking at. You could have other sets related to time periods. For example, you could define quarters within your calculations, and then you can use your index for quarter 1, 2, 3, 4. Another thing that's important is parameters. We sometimes talk about variables. They are interchangeable in the context of what we're doing in the ICS. Generally, where we use parameter, it's been to define an input value, and the variable is to define an outcome or a calculated value. But in general, we can talk about both of them being parameters or both of them being variables. So the chapter on sets and the chapters on parameters will be important. Other than that, it's left to the reader to explore the wonders of the programming language.
In fact, I've checked the website out. There's a bit of sense of storage on the Angular.
Yes, I do. So that is the documentation. Okay. To get down to the methodologies and the projects, both methodologies and projects have got 3 menu items. The first one is a directory, either a list of the methodologies where guys are willing to share what their methodologies are. Those are listed there for whoever's willing to share. My methodologies is specifically talking about the methodologies that you're busy developing and working on. The third item then is to create a new methodology. Very similar on the project side, directory of the projects that are happening, a list of your projects, and then the option to create a new project. So this is way too small, so I'm going to actually switch to the actual website. And maybe I should show what it looks like once I'm logged in. I'm using Serena's details because she's created some example projects that you'll use in later sessions. So I want things to look the same. So if we look here under methodologies, if we click on the methodology directory, we can then see, you can make this menu disappear if you want more space. And we can make things a little bit bigger. So in your methodology directory, it will then list the different component methodologies, who created them, what the status of that is. At the moment, we're in the demo and on the development platform because I don't want to modify anything on the live platform. But when you create your logins, it will be in the live platform, and you can do whatever you have to do there. I'm also going to log out again, and I'm going to actually show you what it looks like when I'm not logged in as someone. So what you'll see here is we can see view public comments on that component methodology, and I can download submissions. But now what happens is in TISO, we want guys to log in and to register and to develop their projects. So you can see the options that are there, but it'll ask you to log in if you want to look at it further. For public comments, you can still give comment.
On this. Oh, okay. Yes, okay. We can view other comments that people are posting.
Yeah.
Yes,
So what happens during the process of developing a methodology, when you're at a point that you want approval, there's a period for public comment. And then guys can go there, submit their comments.
Yeah, but I see us do something similar to the BCA or the Bureau where they send a newsletter out and say these are the kind of projects that are up for public comment right now.
We have been debating having like a bulletin type board where guys can register to receive reminders about things. And then that's one of the options we're looking at.
Cool.
Yeah, you should open this.
How long are they up for comment?
I think it's 30 days. So I'm now I've logged in again. I can then go and look at my methodologies. And then you'll see there's a little bit more information available here. Like I'll see what the status of my methodology is, whether it's something that's been drafted, whether it's something that has been submitted for approval, and then there are later stages within the project that'll come up. We'll also see things like the sectoral scope, and then there's something called an example project. This is important for demonstrating how one would use your component methodology. So you would start off, create your component methodology, and then say, create an example project that uses that component methodology along with the other component methodologies that are required to make a complete project. So you could use a project description that already exists, an additionality and baseline that already exists, as long as they're compatible with each other, and then your monitoring component methodology. What this then allows you to do is to go through the collection of data for that example project, which may be for a short period of time. And then you can actually show that emission reductions can be calculated for that example project using your newly developed component methodology. And for us, this is an essential bit because many of the things with the other standards, with the development of the component methodologies, is you don't know whether it actually gets to a valuable or usable result until you've actually started your project and you're using it. So here an example project is essential, improving the workability of your component methodology. It also helps sort out questions related to what sort of format is your data captured in? Is it in the correct units? So example projects are also useful tools in validating the overall process of your calculation. This one is zoom out. Then within the table, you can then go and look and see there are different actions related to your component methodology. Like if it's still in a draft format, you may want to go back, make some changes, edit the calculations, or add to it. You can then go and say you're ready for your project to be approved. You can then go and assign an auditor for the validation of that component methodology. Review and submit is one of the options. Maybe you've got two people in your company that are working on a project. You can have different roles defined in terms of your company, where someone can be the person that develops the methodology, and then you can have somebody else that'll actually be the one submitting that methodology. And then you can download that methodology as a PDF document that defines these are the sets, these are the questions that you intend the project developer to answer. These are the equations and the calculations that we've done. So,
If one has a component methodology and say is specific to another component methodology, say like a monitoring for a specific project CM, and one upstream or downstream from the monitoring changes or gets reviewed, does that automatically trigger your component methodology to be like, hey, we changed this and this? You see if we need to update. Well, there's lots of moving, obviously lots of moving parts in this in the chain.
So what happens when you create your component methodology? You need to consider what it's going to be dependent on. So those are the ones that are feeding into your project, and it's most likely to be that a baseline or an additionality component methodology would then feed into your monitoring. Methodology.
I thought we only have so.
The question, please.
Yeah, sure.
Maybe a little louder.
Sorry. I was asking if one has a component methodology that's dependent on other ones. If the one that's not dependent, so I assume the parameter methodology changes, does that trigger your methodology to have to be altered?
Okay. So to summarize the question is when your component methodology is dependent on another one, and you require more information in terms of your component methodology, how do you deal with it? Now, in terms of what do you require for a new component methodology, if that baseline, for example, does not provide everything you need in your monitoring, you actually need a new baseline component methodology. What you can do is you can start off with an existing one. You can then modify that and submit that for approval as a new methodology, and then you use that new methodology in your second new component methodology.
I see the methodologies have got expiration dates. What if one of your methodologies expires?
So I think we also need to look at what defines when something would expire. So for example, I think it would be a requirement for a baseline for a grid emission factor to expire.
Yes.
Because your grid emission factor is always changing. And I think this is something that the Environmental Integrity Committee should review in terms of the expiry of.
So is it possible to write a methodology to determine automatically a grid emission factor subject to certain parameters or variables being inputted that have changed and are public information?
Yes.
So you could theoretically write a methodology that never expired,
yes,
subject to variables which change.
yes, yeah. So, and there's also the idea of landmark values. A landmark value would be, there's a calculation for a grid emission factor, and that grid emission factor will expire. But you could use an existing component methodology for recalculating the next grid emission factor that would be needed.
Yeah, so coal, gas, solar, wind component, the whole grid, and those proportions change. Yes, but nothing else.
So the idea then with the landmark values is that someone would have a project. They would use that baseline methodology that would calculate your grid emission factor. Then they would use it. Then someone else comes along and it's a couple of years later, and they then want to use that methodology. They can use that existing value in there for older values, but they can then go through a process of calculating a grid emission factor that can then be used by other people as a landmark value that can be reused. So we're now looking at my methodologies. There are different actions I can take on those. And I think what we're going to do now is actually look at, well, what's required when I actually go and create a methodology. So I'm going to show my menu again. Methodologies, I'll go new proposal. So when you start off with a new proposal, it outlines what the steps are. You then have documentation, which links to the previous window that we saw, and for some terminologies, which is like a glossary. I'd say start. Okay. What you first encounter is really give your methodology a name. So here we could say new example method for
Mining biomass from there.
mining. And just to make things quicker, I'm going to put that in the description as well. Motivation for creating a new one. Okay, the most obvious one is there isn't a current methodology available for doing this calculation.
And it's desirable.
Okay. We then have the option to give more description related to that component methodology, like what sort of component methodology is it? Is it a baseline? Is it additionality? Is it a monitoring? I suspect in this case it's a monitoring methodology.
I mean, the idea would be to reduce methane emissions because you're removing the putrescible fraction which generates methane. So it's methane emission reduction. It's the opposite of that.
Okay, and it's an emission reduction as opposed to greenhouse gas
Reduction.
reduction. The sectoral scopes. This
Waste
is
management, waste handling and disposal.
waste handling and disposal. Okay. And then here we would say what it may depend on. So you're likely to have a baseline for gas from landfill.
Yeah, so I mean, it's the inverse of the current avoidance of putting waste into it. You just turn it upside down.
Now, we can put this in here. It would be useful before we create this methodology to go and look and see what baseline methodologies
Yes.
are there. And then we can refer to that one here. Just as a means to reference back. Okay, then over here, this is the option. Do I want to make this methodology viewable by other people in the methodology directory? And we can choose. And then we can say so now what it's done, it's given a unique number to my methodology. Over here, it provides a description of the information that we've just given it. Here's some information about the status of the project, or sorry, of the methodology. A code, what version is this? Is this a later draft? You'll see as time goes on, as you modify it, these numbers change. It says what type, what category, sectoral scopes, and this hasn't been submitted. Okay, so all this stuff is what we gave in the previous. Then we get to things that we haven't seen before. And we spoke about the component methodology as being a template for collecting information about a future project that may happen. So there are two sorts of things that we need. We need questions that solicit information about the project. And then there are things that we use to define the mathematics or the physics behind the project. So things like what parameters are being measured. What sets do I need to define the boundaries of those parameters? So when we start here, you'll see we've got these things. What are the component methodology questions? And this is going to ask, well, provide us a description about the location of your project. That would be something you could put here. There could also be something about the ownership. Who are the project participants within your project? Then we've got what's called a, excuse me.
There you go. That's a good. Fine, that's it.
So in your calculation workspace, we first of all define the sets that we may need in terms of your methodology. Again, the sets are a list of items that you may need to list through when you're indexing a certain parameter. We then have the parameters themselves. This would be things like temperature, pressure, electricity generated, whatever may be used in the calculation for calculating emission reductions.
There may be several ways to do it.
Yes.
So if you're taking waste out of the landfill, in order to calculate the emission reduction, you would need to know the biomethane potential of that waste. But that's already been calculated in other methodologies when you put waste in. So you could adopt that as avoidance. Or you could measure, or you could measure the actual site and measure the reduction.
Okay.
So when you have multiple ways of measuring, should you measure multiple times or should you make it as simple?
So our preference is that a component methodology is as simple as it needs to be to prove emission reduction. If you want different ways of proving emission reduction, create a separate component methodology for each one. But effectively, you would only need one for the project that you have in mind.
Now, I want to do a group project because I'd like to have legs throughout sub-Saharan landfill. So that if we go and mine a landfill, first we determine the BMP, or we use the calculation that already exists. And then I have a weighbridge that's connected to the interweb. Every time I go over into it, ping, 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 IoT, everybody's happy.
So the way of calculating the emission reductions is purely up to you, and you have to show that it conforms with the principles of the emission reduction, and then that the EIC would be happy in terms of approving it for use. And so there could be 3, 4, 5 different ways of calculating those emission reductions. The idea is to be as simple as possible, so that you reduce the amount of time required, first of all, in monitoring, but also in terms of verifying those reductions. So when you're creating your component methodology, you go through the steps of defining the questions to get information about the proposed project. You then define in the calculation workspace the sets, or sometimes I'll talk about the dimensions of the problem, or the domain, or the boundaries of that problem. You then define the parameters that get used in the calculations, and then you define the equations. And one would do it in that order. It doesn't mean you can't go back and add another set later or add another parameter. But generally, you can only use the parameters you have in the equations that you're building. So if you find you need to build an equation that has some other parameter you haven't defined, you then need to go back and define that parameter for your calculation.
Is the monitoring component methodology not super reliant on the baseline
Yes.
one? So you can't start plugging in
Okay.
just anything really. You have to follow
So
the scheme of project.
yeah, so you would need a baseline methodology, and the way the compatibility works is that you would use the same parameter in both the baseline and the methodology, and you need to define that parameter in both of those component methodologies. Or if you're using a baseline from somebody else, you need to go and study that and make sure you understand how it works. And then you'll use that parameter as they've defined it, and redefine it within your component methodology. Then when you create that example project that we spoke about, the system takes it and says, okay, this is the same parameter, and this is what defines the connectivity between the puzzle pieces, between the baseline and your monitoring.
I suppose the biggest thing you need to is the difference between the variable that comes out of that parameter.
Yes, well, they should use the same name,
Yeah, yeah.
and the same structure. So if you have something called flow rate landfill gas, you then need to use that exact same name in your component methodology. They also have to be defined for the same boundary. So if you define your flow rate in the baseline by site, by month, and by product, then you need to define it in the same way in your monitoring methodology, by product, by site, by month, because that would then make them compatible by the name and the definitions of that boundary or the domain. So let's go through. So what's going to happen in the later sessions is Serena's going to take you through some specific examples. So I'm just going to show you here and there, okay, how do we add a parameter, or how do we add a set, and then you'll apply it when we go to those examples with Serena later this week or next week. So where we start here in the defining those questions is we create subheadings. Where we could have, okay, project description and then owner details and then so on. So here we could have, this is going to be project. Now remember, because a component methodology defines the template for a project, the section that I'm putting here is called project description, but we define, we're creating the methodologies. Okay, and this is going to be for this over here is there are different reports that can be produced. Different reports may include different levels of aggregation. So it's not that important with the questions, but with the parameters, what I can do is I can say in my monitoring report, I only want to show stuff that's aggregated per month. I don't want to show every minute of gas flow that I've measured. So this is used for that in defining the level of aggregation and what's included in the report. Okay, this here is just to help with the formatting, so I don't have to create the template in the order in which it's finally going to be. I can then say, okay, this heading must come first or third or fifth. So that then is to create an order of the groups. Okay, so here we are, we've got our first group. It's called project description. And then if I expand that, I have these options here. And the first thing here is I want to add an input field. And I can then choose, is it going to be a paragraph? Do I just want a one-line statement? Do I want it to be a number input? So it's defining the data type. Project description, I think, maybe here we're going to say, describe the boundary for project. Okay.
Geographical or
okay, define the geography. And then I could have another question that says define the organizational boundary or define the ownership boundary or whatever you want to put there.
something with additionality? There's questions of geography because there's legislation that is different in country to country. So the boundaries could apply.
So there's so much freedom in how you define this that you may restrict the future application of this methodology by saying yes. But you can restrict it or you can expand it depending on how broad you want it to be. The question
where
is
those actual boundaries may exist to the validity of your project, which may be legislative, climate,
this help text here is to prompt for certain information that you may be looking for. So here we could say provide okay terms of maybe province and city, something. Yeah. So this is really to provide guidance to the person using that template that you created. And we can say whether it's required or not. And then again, within that section that we created, we can then order the questions the way we want it. So in this case, we'll also make it the first one.
So you can write question 100 next and then you get there later.
Yes. So here you can see we've got the first group, which is called project description. And then here, the first input field is describe the geographical boundary for a project. And then a little bit more information. You can then edit, delete, whatever, you can also delete this section. And so you would go in terms of building up that template for the information unit. If we now look at, okay, there are two, remember when we created the, I want to say question, but it asked whether it's for the monitoring report or for the project report. So it is possible to define certain information that you want for the one and something for the other, or you can define it for both. So this is going to be exactly the same as over here. You would define the groups of questions or the sections within your template, and then the specific field that you want to get. Okay. In the calculation workspace, there are certain things that are defined by default. All projects have got monitoring periods. All projects have got crediting periods. So these are built into the platform. But we are going to want to add a set, and this set could be, well, months seems too obvious there. You can give me one, maybe province, city. We can call it sites. Okay. A symbol is what we use in the calculations. So you may not want to write site name every time you write an equation. So here we can maybe use a symbol called ST. And then this is set to contain all the sites for the project. Okay. You can also, if it's a numerical field, you can say what sort of units it is. For sites, it's not going to have a unit. It could be numbers. It could also be letters. What's
Then you might want to add up the size.
yes.
So the set needs to be enumerated.
So you can use things like aggregate functions, and you can say count the number of sites in my set site, and then it'll return the number. And that doesn't need a numerical value as the thing that you're iterating through, because they're just placeholders, or they're just an index. They don't necessarily have meaning. It is possible to add meaning to an index to do a calculation. But maybe that's in the advanced course. Okay, we'll get to that, because there are some places where we do that, particularly when it comes to finding differences between dates. Because you can store that date and time as a character string, but then it also has value in terms of how it's represented as a number. Cool. So we can go save. And there's our set called sites, and that'll contain a list of the sites that we may use. Okay. And I do just want to add another one, which I'm going to call months, just to
Can we at least change the names of the month? Lunar month.
Okay, you want to call this one lunar month. There are some stylistic questions in terms of how one may want to name your sets and your parameters. In terms of things like whether you use singular or plural. And so for me, I would always name my sets in the plural, because the individual items within that set is a site. So I'll have my set called sites, and in sites, I'll have a site called site one and site. But those are really stylistic in terms of what you're comfortable with. But sometimes it's quite important that you define that style that you use.
Next for immediate understanding.
Yeah. Okay, and this here can be a number, or we can leave it. This here will we've defined a data type called timestamp, and this will actually save that month as a Unix timestamp, which then can become useful in later calculations. But in this case, I just want to call it. I don't want to call it. I'm going to leave it none. Okay, so now I've got these two sets that I created. Now I can come and add a parameter. And in this parameter, it could be the temperature. But maybe it should be something more than just temperature, because I could have 10 different thermocouples depending on what my project is. So, we maybe exhaust temperature may be better.
So that's a set.
No, I've moved on to parameters.
So we're going to temperature 1, 2, 3, 4, 5, 6 is a set of temperatures.
So when you create a parameter, the parameter is an actual value that you're measuring.
Okay.
And you can say, I want to measure the temperature at the site for this month.
Okay.
And then the month and the site are going to be the indexes for that parameter. So if I wanted to know what was the temperature in this month, at the site, I would then say temperature, and I would give the month and the site, and then it would return the value. So the parameters you do calculations with. Your sets, you don't do calculations with them. You can, you don't necessarily need to. But the main thing for the sets is it creates an index for your parameters. So this is going to be exhaust temperature. I'll give it a simple called exhaust T. Okay, and here, this is going to be something that we measure. It's an input parameter. And my unit here, we should have Celsius. Okay, how about Kelvin? All right, okay.
No.
There must be one. Okay. Robert, are you online? Okay, well, did you see Fahrenheit?
Hi, Philip. I
Hi, Robert.
our list of units. We might not have the unit that you're looking for.
What units do we have for temperature?
I'll tell you just now.
Okay.
Of course, we don't want everyone to add their own units and add temperature in several different ways. So I actually can't find the temperature unit. But I can
Okay.
add it quickly, and then you can reload the page. And what unit do you want?
Just the degree centigrade or Celsius, or Kelvin.
Okay. I'll give it to you in degrees Celsius.
Okay, in the meantime, I'll just fill in these other
No,
fields
please,
here.
please hold on. You'll have to reload the page.
Oh.
Please reload the page now. And see if you have the unit.
What did you call it?
Celsius.
It's okay, we can move on without defining the unit now.
Okay.
I take it we can come back and edit the unit.
Yes, you can.
Okay, cool. So what we did here is we defined something called exhaust temperature. And we gave it a symbol. This is an input parameter. We can define the unit. I'm sure we can come back and do that just now. And this is going to be the exhaust temp from the. Okay, and the purpose for this, like with most of the parameters, is to calculate the emission reductions. Okay, and then over here, what we can do is we could define that boundary of the parameter, and we can use the sites and the months. So now when we refer to the exhaust temperature, we then need to say for this site, for this month. Okay. This here, it's not always necessary. What you can do is for each data point that you collect, you can have a timestamp, and that then will define like the primary means to refer to that parameter, but it won't be essential here. A month may be a good one. The frequency that we're going to collect this is monthly. The source of data, okay. What happens here is that we've got different ways of collecting information. And we've spoken about the IoT, and we've spoken about manual data entry. And then also the landmark values. So it could be that you get a value that's been calculated in another project that uses the same methodology, and that has got the same defined boundaries. And then you can say, use that value, which is what the selection of the landmark values say.
So with the IoT devices, does that need to be connected 100% of the time? Or can you have a device and download the data and it sends it into it?
So the IoT device, the whole intention there is that there's no human intervention. And that's so that we can take shortcuts in terms of the verification during the audit process. So if you mix IoT with other, then that's going to bring into question the process for expediting verification, because now the auditor is going to want to go and check that the values that you have there haven't been tampered with.
I was just thinking of a remote site with no cell phone signal.
Yeah.
And once a month, the manager goes past with his cell phone, gets the data. When he drives into contact, it zips it out.
So I guess that's debatable what IoT is. I don't think it has to be something that has to be permanently connected. But the data collection needs to be automated. But you can automate at certain frequencies, which I think is fine in terms of IoT.
How would one pull in a landmark value into your component methodology from another project?
So
That's, sorry.
what we're still building that,
Okay.
but the idea is that well, you would get a value from a project that uses the same methodology, component methodology as your project, and it would also have to have the same lunar month and the same sites. And then it would automatically pull that number from that other project, and that other project has to have been verified.
So it's similar to like a sectoral benchmark or something like this.
Yeah.
Would it be then treated like a constant?
The way we've been wording it is that it's a previously verified value.
Okay.
So emissions reduction factor that's published by SOT.
Yes, yeah. In this case, I'm just going to say a manual entry. Here, the measurement method can be through thermocouple.
The only last thing on this landmark, like you're saying, from SOT, so it doesn't have to be a project, it can be a verified source.
Yes,
An article, a journal article.
yes. So the main thing is verified by an auditor for another project within the ICS. Project A, they'll have their project, they'll have the emission reductions verified, and one of the values going into that emission reductions calculator has been verified by an auditor. That value can then be used in another project.
So I mean, if we go and we say, if you put a ton of municipal waste into landfill, IPCC 6 says that you generate 600 kilograms of CO2. That's a value, and then we use 0.6 as the constant on the landmark for linked to municipal.
Yeah.
And then when IPCC 7 comes out, we change.
Can you add dependence on that landmark value? Say if site A falls in a similar geographical area, that then use landmark value. If not, so like altitude, for example, in combustion activities,
So
or radiant.
in principle, yes, but it comes down to how you've defined that parameter. And remember, the value has to come from the same methodology, for the same parameter, for the same defined sets that you have there. You could try create another component methodology that fits in and that does a lookup between the one set and another set, but that's really going to get a bit tricky. So with the quality procedure, quite often there's a calibration that's required. And then what one can do is you can specify like according to manufacturer's specifications. And this quality procedure is then something that the auditor would check. Okay. We do have a mechanism to record calibration events. And then what happens is in the calibration events, you say when something was calibrated. And what will happen then is when you do your emissions calculation, it'll check and see whether something's outside of calibration or not. And then you have to build into it a calculation that does a delayed calibration or an adjustment based on how much it's out. But again, that comes down to you to define how that adjustment would be calculated. Quite often what's done is you can look at the tolerance and the error that gets measured during calibration. And then you can adjust the values that you measured by that error that was picked up during calibration.
Retrospectively, and please,
Yeah. Okay. This again is related to that, whether it's included in the report, because you don't want to include data from every minute in a monitoring report. You would want to give monthly data or quarterly data. The idea is that the auditor may want to go and look at the raw data, and then they can access the platform. They can go and look at the minute data and maybe take out a month of minute data, do their own calculation, and then compare it to what's in the report. So this one here, I think that's fine because this is being measured once a month or once a lunar month. So we can include that. Okay.
British thermal.
That's the energy unit, but anyway, not a temperature. We'll just take that for now. Okay, cool. So what we have now is we've defined these two sites, lunar months. We've then defined our parameter here, exhaust temperature. And then you can see that this is an input parameter. You can see the units, and we can go and look at the other information that we captured them. Cool. Sorry, there was one thing I didn't highlight. In addition to the menu that you have on the left-hand side, there's also this breadcrumbs. And this tells you where you are within that menu. So here you can see where it's component methodologies, proposals, and we're busy working on this one. You can also use this to navigate forward or backwards to where you want to be. So there I clicked on the methodology name, and it's taken us back to the summary page for the component methodology. Okay, and then there's equations. At the moment, we don't have anything. We need another parameter to do equations. So maybe let's add one. Probably temperature wasn't the best one to choose just now. This one could be like flow. Oh, there's Kelvin.
Can you not write your own?
What we're concerned about is that everybody adds their own, and then you've got meters cubed, and then
And
meters.
it doesn't understand the unit, does it?
So
So it could be milliliters or
the
meters.
secret is you don't actually need units because it's dealing with the number there. What's important about the unit is that it adds meaning at the end.
Yeah.
So it also makes sure that the user is consistent in terms of the different units that are being used. So if you have flow rate in kilograms per hour, and then you're multiplying that by,
Meters per minute.
yeah, then so the units are really there to guide the user in terms of how they do the calculations, but the unit themselves are not.
So you could
used-
write whatever.
You could. It won't change the number that comes out at the end.
Just the mean.
Yes. So I'm just gonna select anything for now. And this is flow. Again, this is, so this purpose here, it could be for an intermediary calculation, or it could be a final calculation. I guess the purpose here is just to give an idea to the auditor. How is this value being used? And I'm gonna choose the same. This is gonna be. Okay, again, this the calibration procedure. So once per. Say yes, yes. So now we have these two parameters that we've defined. We can then go to equations here and we can say, okay, I want to add an equation. What it's showing me at the top here are the parameters that I can use in those equations. We provide some sort of guidance. There is a syntax that's defined in that 400-page document. Generally, what you do is you use square brackets when you use that parameter. You'll see curly brackets that get used when you're going to have an aggregate function. And you use those curly brackets to show the loop that you're going through. So in your curly brackets, you'll say, okay, I want to loop through the set of sites that I have. But we'll get into those examples in the next couple of sessions. Well, there is an example here. So here we're doing a sum. We define an index that we use. So this could be site in sites. And we can then say flow rate and site. And that's going to then sum up the flow rate. And not that you would sum the flow rate, but so the first thing you do when you define your equations, you define the domain over which that's happening. And in this case, if we're going to be using our two variables that we have, or our two parameters, they've both defined for the same period of place. So our equation can then have the same sets. I don't know what temperature times flow is going to give us, but it's going to be an energy term of some sort.
BTU per cubic meter per hour.
This is energy. Okay, and then this is where we would put our equation in, which is going to take this format. We're going to have our symbol. And there we're going to define the site. And what was the other one? Exhaust, no, lunar month. And
It's even like this.
um, change the BST. Okay, and what we haven't done is we should have defined a variable. So the variable is being calculated from our two input parameters. So we should have defined something called maybe energy. And that would be for our site and our month. And that's going to then be equal to our temperature times our flow rate. And we need
So where
to,
do we define the variable?
we define it in exactly the same way as we define the parameters. So I wonder, this is gonna annoy Robert. That's okay. So in our workspace here, under parameters, we should add a parameter,
Okay.
which will then be energy. Okay, the symbol could be E. And this parameter type here should be the output variable. And then what we're doing is we're assigning the product of the temperature and the flow rate to the energy. And that it's going to have the same dimensions or domain.
So the sets are really important
Yes,
because it defines your model.
yes. And generally, depending on how complex your project is, there'll always be some sort of time dimension to it. But the other dimensions, it'll really depend on how complex you want to make the project. So whether you have 10 sites, maybe you've got different technologies used at each site, or a combination of sites. So you could have a time dimension, a technology dimension, and a location dimension. But you'll see as time goes on how useful defining these sets can be. But also what happens is the more dimensions you have to a parameter, the more data intensive it becomes. Because now just with those three, if you have 10 of each, then you need 1,000 values just to represent the whole data set that you have just for 10 months. So the more broadly you define your parameters, the larger the data set is that you're going to be dealing with.
But it's all automated, so it doesn't matter.
Unless you're capturing
Yeah.
your values manually, then you can imagine if you're collecting minute data for a landfill site, that data grows very quickly. Okay, so I'm going to completely confuse this thing. Now I've got, this should be E. One does need to order the equations because it's procedural in the sense that if you're doing a calculation that determines the value of a parameter higher up, you have to do that calculation before you use it further down. So this again, like with the ordering of the different sections within your template, here you're defining the order of your equations. It may also be that when you're developing the methodology that you remember, oh, I actually have to include this equation, and then you don't want to manually have to reorder things.
So you need to determine E before you can determine rands per value of units.
Yeah.
Sure.
Okay, cool. So here we've defined the component methodology questions. And we then, in our workspace, we define a couple of sets. We then define parameters. The parameters use the sets. And then we define our equations. And that is really what goes into building a component methodology. Now, what could happen is you could have 20 or 30 different parameters. And they all go through some sort of calculation procedure to come to emission reduction calculation at the end. In the methodology manual, we define some fundamental equations that you need to build into your component methodologies. And that includes that emission reduction is your baseline emissions minus your project emissions. So all monitoring component methodologies will have that fundamental equation.
That's number one.
That must be built in. It won't be number one because it's the final calculation that happens. But it is also possible that that equation can be represented at different levels of aggregation, because you can work out your emission reduction on an hourly or even a minute basis. And then you can aggregate that at a monthly basis, or you can aggregate it for a monitoring period basis. But each of those levels of aggregation that you'd want to do would need to be built into your methodology as a calculation.
All right.
Okay, so just to summarize, so we went over what happened in the previous sessions in terms of the principles which are represented in the standard, and then the concept of having different component methodologies. They each form a certain part in the role of calculating emission reductions, approving additionality, or doing a sub-calculation into the process. Then today what we looked at is the platform, how to navigate, how to register, and then how to go and look at the different component methodologies that are there, how to look at the projects that are there, and then how to go and look at your own projects or methodologies, and then the basics of adding component methodology.
If one has experience with, say, kind of an ECA or something, it's really those little blocks at the bottom is what it feels like. If you view that, it has a similar layout.
Yes.
I'm not that it's essentially.
So there's the design document.
In the PDB.
Yeah, the project design document, and then also the monitoring report. And the monitoring report is essentially that design document populated with things that actually happen. And the whole idea here is that now we have our, let's say we have our project.
How many tiers of emissions do we have to go to? Primary, tier 1, or all the way down to tier 2? I mean, if we're looking at taking waste out of the landfill, we look at all the emissions on site, but do we go further down?
Generally, the emission reduction projects are only reduction of direct emissions. So there's no, I mean, besides electricity, where you would have a baseline for a grid emission factor, you don't really go into the whole chain of it.
So I mean, I don't have
Because
to
it's-
account for the diesel and the yellow plant and equipment and the transport of the labor and.
It'll depend on the project because, for example, let's say you have a landfill gas project, and now you're impacted by load shedding. So you install a diesel generator. And now your diesel emissions from that generator, are direct emissions from that project.
Yes.
So your project now has emissions.
So I'm saying if I have a
So-
yellow plant, you know, it goes there digging up a landfill, I'm using diesel, I measure that diesel, but I don't have to go to the transport of the labor, my transport.
No. No.
So it's primary emission. No,
But I think many of those things would happen irrespective of whether the project's there or not.
true.
So it's about how you
So it's truly additional because you're doing more with the same.
so I think that's everything for today. It's all I'm capable of doing for now. But are there other questions from Egmont? I think it's just you. Maybe Lisa?
Yeah, I found it very insightful. To be blunt, I have 1 or 2 methodologies in mind, and I have to actually go and do them. And I think then a lot of questions will come up.
Okay.
So Mike, maybe you and I need to work together on, I don't know, something related to organic waste, and we can think about it.
Left. I reckon we can do that mining of landfill quite quickly.
Yeah, maybe you and I need to sit together and do
I mean,
that
it is
mining of
so
landfill
simple.
one.
It's- You know, we calculated going in as per IPCC 6 method, whatever, blah, 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 blah. And we take it out, therefore minus.
Yeah, it's not that complicated.
It
So-
can't be. I reckon we can do it in the session and we can smack it out and we can start using it.
Yeah. So Philip, I'm quite impressed by what you guys have put together. So yeah, I'm gonna start playing with it, and please be ready to answer any stupid emails. How do I
Okay,
press this button? What happens if I do this?
So on Thursday, we'll actually start working through some
Okay.
worked examples where we've gone through we'll go through the whole process and come out with emission reductions at the end.
Okay.
Good.
Yeah, I look forward to that.
Maybe we can get together on Friday.
Okay.
Great. Thanks for your time, guys. And,
Thanks, guys.
any questions, guidance, and so on.
Okay.
Thanks.
Thanks, everyone.
Thanks,
Take
Lisa.
care. Bye.
Cheers.
Thanks, everyone. Bye.